Hey folks, welcome back to another lesson, and we're looking at ionisation today. Now, some of you who are doing chemistry will know that ionisation is the process of making ions, but in physics we're going to look at what causes this ionisation. Okay, so we're going to start by defining ionisation. We're going to look at the ionisation abilities of alpha, beta and gamma radiation. And we're going to give examples of some of the applications of radiation and describe how radiation can be detected. Now, the nice thing about this lesson and about radiation in general is that a lot of it is just information you have to remember. So a lot of this will be me giving you information, and then I'm going to set you a task to do a bit of reading so that you can learn more about these different kind of aspects of radiation. Okay? So let's recap from last time. And last time you might remember seeing this diagram, and I said that when radiation passes through a material, it gets absorbed. So remember the three types of nuclear radiations are alpha, beta, and gamma. And this is the type of range of these radiation, and this is what they are absorbed by. So again, this is information that you need to know. So I'd like to copy this down. And remember, alpha has the shortest range, then beta, and then gamma. And then alpha is absorbed easily by a sheet of paper, a thin sheet of paper. Aluminium by 2 to 3 millimeters of, beta by 2 to 3 millimeters of aluminium. And then gamma is usually absorbed by really thick lead or concrete. Okay, so you can see that of the three radiations, alpha is the easily absorbed, beta is the medium one, and gamma is the one that can penetrate the furthest. Okay, so there's a wee video that demonstrates the range and penetration of these three radiations and what materials absorb them. I'll leave the link in a separate file so you can watch that video. Okay, now, how can we use this knowledge for applications? Because obviously we use radiation in a variety of ways, and I don't want you to think of radiation as a bad thing. It can be a good thing. So here's an example. A nurse is using radiation to treat a cancer patient, and the cancer is located in the lungs. State which radiation you would use and justify your answer. Okay, so pause the video and have a rethink which of these radiations would be the best one to use. Okay, so hopefully you've tried that and you've given me an answer. Now for me, the answer would be either beta or gamma radiation. You definitely wouldn't use alpha, and hopefully you're able to tell me the reason for that is because it's got a short range, so it's not likely to get very far in the body. And secondly, it's really, really easily absorbed, so it's more likely to be absorbed by the skin and it wouldn't go any further into the body. You could use beta and gamma. Now, beta, again, it would depend on, which part of the body you're going through. But because it's absorbed by aluminium, you would hope that the bones wouldn't absorb too much of the radiation. To be on the safe side, you probably want to use gamma radiation because you know it's got the greatest range and also it's not absorbed by any material in the body. Okay, so just in case you're not sure, here's the written answer. Beta or gamma as both travel far enough through the body to reach the cancer in the lungs. And later you'll see there are other factors that we have to consider. Okay, so having looked at the range and a brief application of the three types of radiation, let's look at what they actually do when they come into contact with atoms. And what they do is something called ionization. So this is a definition that you are expected to remember. So ionization means adding or removing an electron from an atom to produce a charged particle. Okay, this is the SQA definition that we want to learn, so make sure you memorize that. So the idea of that is very simple, is that adding an electron will give an atom with an overall negative charge, creating a negative ion. And logically, the other case would be if you remove an electron, will give an atom an overall positive charge, creating a positive ion. And if you're doing chemistry, you'll know this in a lot more detail. Okay, now, ionizing radiation are radiations which actually create ions from neutral atoms. So examples of ionizing radiations are alpha, beta, and gamma. And so literally what the radiation is doing is it's ripping the atoms apart. And because they're able to rip the atoms apart, that's how they damage biological cells. Okay, so again, if you note this down, these are just all information to remember. The radiation rips electrons from the atom, creating ions, and you can usually get negative or positive ions, but generally if you're ripping electrons off, you'll be creating positive ions. Alpha radiation is the most ionizing radiation. One of the reasons for that is because number one, it's a very big particle, so it can smash into an atom, breaking it apart. Secondly, because it's got those two positive protons, you've got an electrostatic attraction, which can also rip the electrons away. Okay, gamma radiation is the least ionizing radiation because it's neutral, so there's no electrostatic attraction like there would be in alpha and beta. Secondly, because it's a wave and it's got very little mass, it can't physically break the atoms up like an alpha or a beta particle radiation can do. However, the wave can transfer energy, remember that from the waves topic, so it can still damage cells that way. Okay, so there's a wee activity for you to do to read up a little bit more about it. I will put this in your assignments if it's necessary. Okay, so a few safety precautions when you're using radiation, and I would demonstrate this in class so you can understand how important it is. Now, you might think, when would I ever use radiation? Well, radiation's come up in a whole range of things. For example, a dentist would have to take x-rays, so therefore they'd have to know how to handle radiation carefully. A nurse who might be working in the x-ray department would of course be working with radiation all the time. If you've got any smoke alarms, some smoke alarms will actually use an alpha radiation source to help detect the smoke. So again, you have to be careful of that. In industry, they can use radiation all the time. For example, it's a very good way of looking for cracks in pipes, because if you've got any cracks in the pipes, then the radiation is more likely to leak through the pipe. So that way you could tell if there was any radiation leakage. Now, in my wee picture here, you can see all the different effects of radiation on your body. You're not expected to remember all of these. I've just shown it you for information. But what are the precautions you've got to take when you're using radiation? Well, first of all, you minimize contact, because remember, the less you touch things, the less likely you're going to get it on you. So you would use tongs, wear gloves and a lab coat. The lab coat's really important because it means if you do get any radiation on you, it doesn't go on your clothes, and that means you don't walk around with it all throughout your day. Or more importantly, you don't take it with you wherever you go. So once you take the lab coat off, the radiation stays on the lab coats, and that stays in the lab so it doesn't get transported elsewhere. Okay, always point the sources away from you. So in particular, you never point it at your eyes, because your eyes are very soft tissue, so they're very easily damaged. So for example, if you go on a sunbed, they usually give you those really cool looking kind of like glasses to wear, and that's to protect your eyes from the UV radiation. Okay, so never point source directly into your eyes. Keep as far away as possible from the source, in particular against young children, because young children, they're still developing, and also they've got a smaller mass, so they're more likely to be damaged by the radiation. So for example, if you go to a dentist and you get a radiation taken by the dentist, they'll probably set the x-ray up, and then they'll walk as far away as possible from the x-ray machine to limit the radiation they get exposed to from the x-rays. So limit the time exposed to radiation. So the less time you spend with a radioactive source, the less likely you're going to absorb it. Okay, have shielding if possible. So shielding could be, for example, a nurse could wear a lead-lined or lead-filled apron. So what that means is that they actually put lead in the apron, because remember, lead will absorb alpha, beta, and gamma radiation. And you always wash your hands afterwards, just in case you get any radiation in your hands. So again, you're not touching things with your hands that might be radioactive or have radioactive material on it. And more importantly, you're not touching food with your hands that have been contacting radiation, because you might accidentally put the radioactive materials on the food, which if you then eat it and it goes in your body, you're exposing your body to greater radiation. Okay, so what are the applications of radiation? We've got medical uses, military, energy, academic, scientific, and industrial uses. And what I'm going to do is I'm going to give you some information sheets to read about for you to actually learn a little bit more about it. But for the next couple of slides, I'm just going to show you some applications which I want you to note down. Okay, so detectors of radiations, X-rays are photographic film. They'll go black if you're exposed. So in this X-ray here, The white bits are the bits where the radiation's been blocked so it doesn't hit the photographic film. Okay, so the bones absorb the radiation, no radiation hits the film, which means the film remains white. Okay, where radiation hits the film, it goes black. And if you work in a nuclear power station, you could be asked to wear a film badge that you carry around with you all day. And the idea is that as you work around the nuclear power station throughout the day, if you're exposed to any radiation, that will hit the film badge and it'll make it go dark, and you can see how much radiation you've been exposed to. Okay, so here's an example of this film badge. You can see there's three windows here, and what these windows have is different amounts of shielding. And that way you can compare the amount of radiation exposed to, and that way you know if you've been exposed to a lot of radiation or not. Okay, so the windows either have no shielding or plastic, thin steel or lead, and this means the film will respond to the presence of different radiation. Okay, another detector radiation which I'm hoping to show you in class is the Geiger-Müller tube, and sometimes this is called the GM tube, and this is really good for measuring ionizing radiation. Okay, another thing which you might use in biology is something called a scintillation counter, and these flash briefly when radiation is detected. So what you can do is you could give cells a biological radioactive chemical, and so that radiochemical will decay. And so if you can detect this decay, you can detect how much of this radioactive material is taken up by this biological cell. Okay, and as I said, there'll be a few worksheets to help you read up more about this.